See, today we have to start the properties of system. First, we have to study the type of system. Then second, we have to study here the properties of the system. Properties of the system. See, here the system property, they are classified into the two parts: extensive property and intensive property. Extensive property and intensive property. Extensive property and intensive property. See, then what is meant by extensive property? Extensive property means the property of system which depends on amount of matter. It depends on amount of matter. Amount of matter. What is called as the extensive property? Means it depends on amount of matter. It depends on amount of matter. Means here, take an example of that property here: mass, volume, internal energy. These are the properties are extensive property. These are the properties are extensive because it depends on amount of matter. Take here volume. At 1 mole volume, it will be 22.414 liter. Then 2 mole, it will be double volume. Means it will be depends on amount of matter. The property of system which depends on amount of matter. It depends on amount of matter. What is called as the extensive property. Means the property which depends on amount of matter is called as the extensive property. Example like mass, volume, internal energy, heat capacity, number of moles. These are the examples of the extensive property. Then second property is the intensive property. Second is the intensive. Means it will be independent. Independent on amount of matter. It will be independent on amount of matter is called as the intensive property. And these properties are, example of these properties are temperature, pressure, melting point, boiling point. These are the properties are independent on amount of matter. Independent on amount of matter. Means any property which are independent on amount of matter is the temperature, melting point, boiling point, then viscosity, surface tension. These are the properties are intensive property which are independent on the amount of matter. Which are independent on the amount of matter. See here the melting point or boiling point. You have to know that boiling point of water is 100 degrees Celsius. Means 10 ml boiling point of water it will be 100. And 1 liter boiling point, 1 liter of water was taken. The boiling point cannot be changed. Means it will be independent on the amount of matter. It will be independent on the amount of matter. See, these are the properties of the system: extensive property and intensive property. Then we have to study here the state function. The next part is the state function. Next part is the state function. See here, we have to study the second part is the state function. Then what is meant by the state function? See here, first we have to relate to the study the state. Means here the state, we have to know that the states of matter, physical, solid, liquid, gases, it will be changes. Here in thermodynamics, that state's function that will be related to the state. Means here it will be considered as the initial state and final state. Initial state and final state. Here initial state and final state means in thermodynamics we have to know that initial and final. Initial and final. Here we have to take the thermodynamic properties, that is pressure, temperature, volume and number of moles. Pressure, temperature, volume and number of moles. It will be changes in initial state to the final state. Initial state to the final state. That pressure, temperature, volume, number of moles. See here in initial state we have to consider as P1, T1, V1 here, P2, T2, P2. Means in final state that will be changed. Means here it will be changed in the state from initial to final. From initial to final. And these are the thermodynamic properties, and here change in the state. state, and these are the state variable from initial state to the final state. These are the thermodynamic properties: pressure, temperature, volume, number of moles. It will be changes from initial state to the final state. See, we have to study here the state. Then state function. We have to study here the term state function. Then what is meant by state function? First state word that will be, we have to study the change in the state, and change in the state variable that will be the P1 to P2, P1 to V2, T1 to T2. That will be the variable. It will be changes from initial state to the final state. Then we have to explain here the state function. Then state function means the property which depends on the state of the system. The property which depends on state of the system. The property which depends on state of the system and not the path. And not the path followed by the system. What to call as the state system. State function. See, means the property which depends on state of the system. Property which depends on state of the system and not the path followed by the system. Path means no path. See, we have to consider here. We have to go to the 4th floor, from ground floor to 4th. You have to use the lift or you have to use the G9. G9 is at your lift is at. Target का है 1st floor और 4th floor लगा है. Not path. Pathway नहीं. It will be go from initial to final. Means state function. They are property which depends on state of the system and not the path followed by the system. Means current state of the system. Or to call as here the state function. Or to call as the state function. Then we have to study here the thermodynamic equilibrium. Thermodynamic equilibrium. Next part is the thermodynamic equilibrium. That will be dropped, but you have to know that the equilibrium means that equilibrium we have to calculate it. In the thermodynamic, that system is said to be in an equilibrium state when the state function do not change with time. When the state function do not change with the time. That's what we call as the, that will be the thermodynamic equilibrium. Means that cannot be changed with the time. That state function cannot be changed with the time. We have to call it that thermodynamic equilibrium. Then we have to study the main process. Here the process what? A process means that equilibrium changes from one position to the another. That equilibrium changes from one to the another. That equilibrium it will be changes. That transition it will be from one equilibrium state to the another equilibrium state, or to call as the process. And there are 5 types of the process. There are 5 types of the process. One by one we have to study here. There are 5 types of the process. 5 types of the process. See here, first is isothermal. Then second is isobaric. Third is isochoric. Fourth is adiabatic. And last is reversible. See here, isothermal. Isothermal. Here process means it will be one equilibrium state to the another. See, transition from that. See here, we have to study the 5 types of process. Isothermal means temperature of the system remains constant. That will be the delta T is equal to 0. Temperature of the system remains constant throughout the transformation, or to call as the isothermal. Then that internal energy of the system remains constant in the isothermal process. Internal energy of the system remains constant. That will be denoted by delta U is equal to 0. Internal energy. Then here, this throughout the temperature it will be the constant. Then isobaric. Baric barometer, we have to use the pressure instrument. That will be the pressure of the system. It will be remains constant. That will be the delta P is equal to 0. And throughout the process, that pressure it will be the constant, or called as the isobaric pressure. And that will be the experiment. It will be carried out in an open container. If delta P is equal to 0, that will be the pressure of the system remains constant throughout the transformation. Then isochoric, core means volume, means here volume property, it will be changes, that volume it will be the constant, that delta P is equal to 0, and that vessel it will be the closed vessel. It will be the closed vessel. Means here isochoric, volume of the system remains constant throughout the transformation. If delta V is equal to 0, that will be the closed. Then adiabatic process, here heat change remains constant, that will be due here the capital letter Q is equal to 0. Adiabatic process, heat change remains the constant throughout the transformation. Means here that reaction in adiabatic process, they have changes, that will be the exothermic reaction, endothermic reaction, means that the temperature it will be increases or decreases, that no exchange of heat between the system and surrounding, that will be the heat change remains constant, what called as the adiabatic process. And here the last process type, it will be the reversible process. That reversible process means here when reaction carried out A to B, that will be the forward direction, but that opposite force means driving force, that forward direction, that opposite force it will be slightly greater than driving force. By changing the condition, that reaction it will be the reverse. And then features of reversible reaction we have to study in the next lecture. Is that type of reaction we have to call as the reversible reaction. Today we have to stop here.